Hello, everyone. Thank you for coming out today. I'm here to present the research road crossing patterns of ocelots in southern Texas. I would like to acknowledge my co-authors, Dr. Jane Anderson, Dr. David Lester, Shelby Carter, Emery Blackburn, Amanda Beals, Landon Schofield, Dr. John Young, and Dr. Michael Tuis. So, roads have a impact on wildlife communities and habitats worldwide, and they pose one of the greatest contemporary threats to wildlife globally. Road impacts can increase habitat fragmentation, decrease habitat population connectivity, and increase wildlife mortality. And indirect effects on wildlife can include altered home range placement and or migration routes, interference of acoustic communications among species, and pollution of air, water, and soil. As human populations and associated road development are projected to continue increasing, understanding the impacts and the mitigation strategies of these roads is critical. So these impacts can affect wildlife species in different ways, and different surfaces can affect them. Road impacts can influence the presence of suitable habitat patches, and this is done by different traffic volumes and flow, as well as road densities within home ranges. And carnivores, more than any other species, are sensitive to road impacts. Now, ocelots in Texas are considered a dense vegetation specialist across the range, and populations in Texas are considered a remnant of a much larger distribution and are isolated from populations in northeastern Mexico. Now, in Texas, there's two isolated populations, one in extensive ranch lands and others in a highly urbanized area along Laguna Atascosa National Wildlife Refuge close to the U.S.-Mexico border. But the proximate cause for ocelot mortality is road mortality, as well as habitat loss and fragmentation. So for this research, we're going to focus on two general areas: the ranch population, which is on extensive rangelands and ranchlands in Willacy and Caney County, and the refuge population, which is located in and around Laguna Atascosa National Wildlife Refuge. So the objectives of this research was to determine the densities of roads within home ranges and where ocelots place those home ranges, to determine the rate at which ocelots crossed roads and whether this varied by road type in each population, to evaluate whether road crossing rates were influenced by sex or by road availability, and to evaluate whether ocelots were subsequently road killed that crossed roads more frequently than those that were not subsequently road killed. So for this data set, we used two data sets. One, a historic data set of 51 individuals captured on Laguna Atascosa National Wildlife Refuge, and the other one, a more contemporary data set from 2013 to 2020, which was 20 individuals captured on the El Sal's ranch in the more extensive ranchland habitats. We for this analysis, we classified roads as dirt, gravel, or paved, and what's pictured here is the dirt, gravel, paved for Laguna Atascosa, and we ground truth those roads in March 2019 and March of 2021. We classified low paved we classify paved roads as having a low traffic volume of below 1,000 cars a day, and medium and high classification as over 1,000 cars a day. We combine medium and high together because of a low sample sizes of ocelots having high and medium paved roads within their home ranges. We simulated the movement paths where we created movement paths by connecting consecutive locations and intersected roads with at least two subsequent locations following the crossing, indicating that a confirmed crossing location regardless of the exact path or angle in which the step was taken. We calculate the rate at which the movement paths intersected these three types of roads. And then we looked at those road crossing rates. We evaluated road availability to each ocelot and classified availability as the density of each road type within the home range and created 100% MCPs to represent those home ranges. We defined each study area in the ranch and refuge populations by creating 100% MCP, and using a Mann-Whitney test, we compared the availability between males and females. For road crossing patterns, we evaluated how road crossing rates were influenced by surface, sex, and road availability. We used a generalized linear mix model for the ocelots from 82 to 2001. And because of a large data set and for the GPS color area, we used the angular transformation for those ocelots from 2013 through 2020. We compared paved road crossing between male ocelots that were subsequently killed by vehicle collisions and those that were not. So for the refuge population in and around Laguna Ascosa National Wildlife Refuge, we found that ocelots crossed dirt and gravel roads more often than paved roads, and road crossing rates were positively related to road availability among all types. So what you're seeing here is the proportion of moving paths that cross roads and the road availability. So as there was more road density of dirt roads, ocelots more rarely cross them. Same thing as gravel and paved, but you see dirt has that above all. They cross dirt and gravel way more than they did paved. For males and females, we saw that male ocelots crossed all road types more frequently than female ocelots, even though males and females did not differ in road availability. Paved road crossing rates did not differ between animals that were subsequently killed by vehicle collisions and those that were not. However, for the ranch population, we only found that road crossing rate was positively related to road availability among all road types. And so for home range placement, we did not talk about the results extensively here for time, but what we saw is that dirt and unpaved road densities, ocelots had greater densities of dirt and unpaved roads within their home ranges than what was available on the landscape in each study area. They had lower densities of medium and high traffic roads within their home ranges than available on the landscape, and they seemed to avoid placing the home ranges in those areas. The use of unpaved roads within their home ranges is indicative potentially of ocelots using these areas as merely openings between patches of brush and not actual roads. And we saw that even in the ranchland populations, where there were much higher dirt and gravel road densities within ocelot home ranges than what was available on the landscape. So those cats are mainly using those areas as mainly openings between areas of suitable patches. And we see the same thing on Laguna Ascosa in those surrounding areas. But they seem to not like high densities of medium and high traffic volume roads. What we see here is that ocelots consistently cross paved roads less frequently than dirt or gravel roads. And this is likely a response to traffic volume on the roads. It's indicative of increases in paved roads, and traffic volume are likely going to alter ocelot movement patterns, especially in the areas in and around Laguna Ascos National Wildlife Refuge, which is in the highly urbanized Lower Rio Grande Valley, which is a rapidly urbanizing area with the adjacent micropolitan area of Brownsville, Harlingen, as well as Matamoros and Reynosa in Mexico. So ocelots consistently cross paved roads less frequently than dirt or gravel roads. And that is indicative of increases in paved roads, and traffic volume are likely altering ocelot movement patterns as well. So ocelots, when we go by sex, is that our finding that road-killed and non-road-killed male ocelots had similar road crossing rates. And this is indicative that males that were subsequently hit by cars did not appear to be simply displaying aberrant behaviors. Male ocelots cross all road types more frequently than females because males typically, once they leave their natal home range, they are exploring the landscape and trying to establish a home range. If there is an area that is occupied by a dominant tom, that male will explore what is in front of him. And for this reason, we would think that road crossing structures designed to increase habitat permeability for ocelots most likely may be beneficial for male ocelots, because they're the ones that are going to most likely be passing over these roads and across these far and distant landscapes, especially when you move further away from the core population. And when we look ahead for management implications here, we can say that we can predict road crossing rates for ocelots when they are monitored. Male ocelots are more likely to cross these roads. Dirt and gravel roads, ocelots are going to cross these at will. And in more ranchland habitat, putting a ranch road through an area, whether it's putting a ranch road through an area for cattle or for fire break or for hunting opportunities is not going to directly impact the cats. Since cats are simply going to interpret that as an open area, and they will cross it. It's not like, but if there's a highway that passes through the ranch, or on the south side of the ranch, for instance, those cats are less likely going to cross that road, and they're less likely to place that road within their home range. Actually, by contrary, they may in fact make that road a boundary to their home range. And with that, I would like to conclude this talk. I would like to acknowledge the funding for the analytical portion of this research, and that is the Texas Department of Transportation. I'd like to acknowledge the East Foundation, who provided funding for the failed operations within the ranchland community, as well as several other entities over the past 35 years, which helped with the data collection of the ocelot locations from 1982 to 2001. And I will take any questions. Thank you.